Okay, hello and welcome back. In this video, we will cover section 2.4 on applications involving percents. So we're still in applications of solving linear equations. This time it'll involve percentages, which shows up in many different kinds of real-world applications, both in finance and in science. So just some general starting techniques for solving problems with percents. The first thing that you often have to do is change from decimal form to percent form or from percent form to decimal, because a lot of the formulas require you to use the decimal form of percents. So just as a basic rule of thumb, if we want to change from a percentage to a decimal, so to change from a percent to a decimal, you move the decimal point 2 spaces to the left. So move the decimal point 2 spaces to the left. So for example, if I had something like 35%, the 35, you can imagine that's like 35.0. So always like a 0.0 next to a whole number. So by moving it 2 spaces to the left, I mean, like imagine picking up the decimal point and moving it, that would be 1 space between the 3 and the 5. And in the second space would place it right in front of the 3. So this would be converted to 0.35. So as a decimal, 0.35 is equivalent to 35%. So when we're speaking, we usually use the percentage form, but in terms of using math formulas, we'll usually use this decimal form. And then to go in the reverse direction, so if we want to change from a decimal to a percent, you just do the opposite. You want to move the decimal point 2 spaces to the right. So just another quick example. If we had something like 0.275 and we want to change this to percentage, we would take the 0.275 and then imagine picking up the decimal and moving it 2 places to the right. In this case, it would go right between the 27 and the 5. So that means 0.275 is equivalent with 27.5%. So just two different ways of expressing a percentage. So let's start finding percentages of some numbers. So in general here, if we want to find a percentage of a number, so to find a percentage of a number, you multiply the decimal version of the percent multiply the decimal version of the percent by that number. And I think seeing an example will make a little more sense. So in example A, we want to find 20% of 120. So 20% of 120. Oftentimes when you see of in this sort of situation, it implies that you're going to multiply. So 20% we will turn into 0.20. Imagine taking a decimal and moving it 2 spaces to the left in front of the 2. So 0.20 times 120. If you do that, you should get 24, positive 24. So we just want to find 20% of 120. In part B, it's asking us the same thing. But if we can think about like translating between word form, if it's saying what is 20% of 120, we can turn this into an equation. So this what, that's like an unknown. Something is, well, something is equal to, is like your equal sign. 20%, convert it to a decimal, 0.20. Of is your multiplication, 120. And notice we have the same thing that we had up here. So 0.20 times 120, well, that's what we just did earlier. So we'd say that something, that what is 24. So just kind of to give another angle here. This is a simple example, but as the word problems get more complicated, it can be useful to do this sort of translation technique, where you write it out and then translate it into an equation. All right, so let's see some slightly more complicated problems. Still solving applications involving percents. Okay, so example 2. The Montes family is driving to Disneyland for their family vacation, and they have already driven 220 miles. It looks like some total number, or some number that they've driven so far. Mr. Montes has calculated that they have completed approximately 75% of their trip. And it's asking us to find the total distance from their home to Disneyland, and then I'll make a note. It wants us to round the answer to the nearest mile. Always take note of this like rounding statement when you're thinking about doing the homework, because you may have the correct answer, but it's looking for a specific kind of rounding. So you may want to do that. Just take a special note of that. Okay, so how should we set this up? We've driven 220 miles so far. So 220, driven 220 miles so far. And so that's 75% of some, so 75% of some total number that we don't know. So this is where it might be useful to put it into words. We're saying like 220 miles is 75% of what number? That's the question that we're asking. Well, let's convert this into an equation. So 220 miles is, so that's our equal sign, 75%. Let's turn that into a decimal, 0.75. Again, imagine taking this point here and moving it 2 spaces in front. Of is our signal to multiply. So I'm using this dot as multiplication symbol. Multiplication is expressed in many different ways. You'll see it like sometimes in X, although now with variables that can become confusing. So this dot is used oftentimes, or you might just put this next to some number with parentheses, and that will also imply multiplication. So I'll use this dot for now. So 75% of what number? Well, that's what we're trying to find. So that's what we'll say is our X, our unknown. So we can say we're looking at 220 equals 0.75 times X. And then we just need to solve. So I would divide by 0.75, divide by 0.75. So it'll cancel on the right. And then on the left, 220 divided by 0.75 will give you 293.3 repeating. So 0.33333. This is equal to our value. And we wanted to round to the nearest mile, so that would just round to 293. So let's state the answer in context of the problem. I would say the distance from their home, so from home to Disneyland is 293 miles. So 220 was 75% of 293. All right, let's look at another example. All right, this says, Lara bought a sweater on sale for $36 that normally sells for $60. So $36 was the sale price. The normal price was $60, and it says, what percent of the original price did Lara save? So what was the discount? It was what percent off? Well, first we need to think about how much did she save? How much did Lara save? That would be our first question. What was the sale? What was the discount? How much did Lara save? Well, we can take the original price, which was $60, subtract the sale price, should be the difference between these. So 60 minus 36 should get you $24. So it was $24 off. So this is how much was saved. So we need to find out $24 is what percent of the total amount, 60. We can make that our second question. So $24 is what percent of the original price, which was 60. And let's translate that into an equation. So 24 is, that's our equal sign, what percent? So this means we're trying to find out the percentage this time. We're trying to find out what that percent is. So some unknown percent of multiply 60. 24 is some unknown percent of 60. So we have an equation. Let's solve for x. So this is 24 equals 60 times x. Let's divide both sides by 60 to solve for x. It'll cancel on this side. And then 24 divided by 60, if you are using a calculator, you should get 0.4. You can also do long division. So 0.4 equals x. So that's the decimal version of the percentage. Let's convert it into a percentage. If we have 0.4, think of that as 0.40. With a decimal like this, you could have any number of zeros beneath it. Like let's say we even just keep it as the 0.4. And we said earlier to go from decimal to percentage, you move it 2 spaces to the right. So one space would put it right behind the 4, and then one other, it leaves this gap. If this is happening, you can just place a 0 there. And then that would be our new decimal. So 40%, 40. So we can say x equals 40%. So let's answer in terms of the question being asked. It was asking what percent of the original price did Laura save? And it was 40%. So I'll say Laura, oops, saved 40% off the original price. And that'll be our answer. So we were just looking at percent and like percent off. It's like a big thing that comes up in these like retail style questions. And sometimes you're interested in how much has it changed, percent change. So let's look at this example. It says a digital scale that normally sells for $32, so normally sells for 32, that's the original price, is marked down 30%. So that's the sale amount. And it's asking us, what is this sale price? So we need to think, how much was discounted? The sale price would be the original price minus the discount. So we can first ask, well, how much was the discount? Well, it was marked down 30%, so we could ask ourselves, what is 30% of $32, the original amount? What we saw earlier, to find a percentage of a number, we just take that number and then multiply by the decimal of the percentage. So if it's 30%, that would be 0.30 as a decimal. So we multiply by 0.3 or 0.30. If you do that, you should get 9.60 or $9.60. So that was the discount amount. So if we want the sale price, you can say sale price is equal to the original price minus however much was discounted, minus the discount. So our original price again was $32, and we took off $9.60. So that result should be $22.40. So I'll just say the sale price is $22.40. So we kind of have this formula. The sale price is the original price minus the amount discounted. We did this in 2 steps. We could have done this part in the middle of this formula, but sometimes it's better just to do it one piece at a time. But let's try to do it 2 for 1 in this next one. So let's look at example 5. It says the sale price of a snowboard, so the sale price is $256, after a 20% discount. This time it's asking us what was the original price of the snowboard. So we'll use a similar setup here, but this time we're looking for the original price instead of the sale price. Just solving for a different unknown. So let me write that little formula again. I can say the sale price should be equal to the original price minus the discount. This time we know the sale price. It said the sale price was $256. So this is equal to the original price. And that's what we're looking for. In this case, this is our unknown. So that's what I will call X. Some original price minus the discount. Minus the amount that was discounted. Well, we took 20% off of whatever that original price was. So we can express this as 20% of the original price. We can call it 0.20 times X. Have some original price here, and we found 20% of it. That would be the discount. So a little bit tricky, but it helps to write out this statement. Think about what the unknown is, and then set up the equation. So let's solve for X. We can think of this as 1x minus 0.2x. So 1 minus 0.2 would be 0.80x. And then let's divide by 0.8. Both sides, 0.80. It'll cancel here. And 256 divided by 0.8 will give you 320. Notice when you divide by a decimal, it gets larger instead of, usually when you divide by some number, it gets smaller. But when you divide by a decimal, something less than 1, between 0 and 1, the result is bigger. Pretty interesting. So this will be equal to X, 320. And that was our original price. So I would say the original price of the snowboard was $320. So it's useful to write it out in words what we're looking for, and then substitute in what we do know, and then use an X for whatever we don't know. Then we can solve for that X. So our next application involving percents is with simple interest. So this comes up in loans or savings accounts, or if you're loaning money or borrowing money. Oftentimes the interest formulas are more complicated, but this is the aptly named the simple interest version. So let's first look at our formula for simple interest. So the simple interest formula is I equals P times R times T. And let's define what each of these things mean. The I is the amount of interest that's earned. Interest is like the extra money that you either pay or receive when you're borrowing or loaning money. Like if I borrow money from somebody, I borrow $20, and I say I'll pay them back in 3 weeks. And then they ask, well, when I pay them back, to pay them back $25. That extra $5 is the interest. It's like what you pay extra for the time spent until paying them back. So that's just a simple example. So I is the amount of interest earned. That's what this formula would solve for. P is what's called the principal. This is just whatever the initial amount is. So this is either the initial amount that's borrowed on a loan, or the initial amount that's put into some savings account that's going to earn interest. R is the rate, so the interest rate, and this is as a decimal. So that's important. You'll need to, if they give you some interest rate, you'll need to convert it to a decimal before plugging it into this formula. And then T is the amount of time specifically in years in this case. So let's look at this first example and how to use this formula. It says if $600 is invested for 1 year in an account earning 4% simple interest, how much interest will be earned? That $600 that's invested, that's the principal. So I can say P equals 600. The amount of time is 1 year, so T would equal 1. It's a 4% interest rate, so our rate is 4%, but remember we need to convert that to a decimal. So that would be, if this is 4, imagine moving it over 1, 2 places. There's an extra gap here that'll put a 0 in, so this would be 0.04. That's 4%. So let's just plug it in. I'll write out the formula again. I equals P times R times T. So P was 600. R is 0.04, 4%. Then our time was 1 year. So if you multiply that all out, you should get 24. So that means $24 of interest was earned. Over that 1 year. Based on that 4% rate. And it's not a lot, but let's say you had $60,000 instead of the 600. Well, that 4% of 60,000 would be quite a bit more. So even a small percent, if it's a large enough number, will produce a large result. All right, let's look at number 7. So it says Gavin invests $1,000 in an account earning 6% interest and $7,000 in an account earning 3% interest. After 1 year, how much interest will be earned? So now we have 2 different accounts. So let's think about how much interest was earned in each one separately, and then we can think about this total. So in account 1, we have an investment of $1,000. So the principal is 1,000. It's a 6% account, so the rate would be 0.06 after converting to a decimal. and this time frame was also 1 year. So we can think of the interest from account 1, I'll say I with a little 1 next to it, would be PRT. Just write this over here for reference, P times R times T. So the principal is 1,000, the rate is 0.06, and the time is 1. So 1,000 times 0.06 times 1. That result should give you $60. So that's our first account. In account 2, it says that he invested $7,000, so our second principal would be 7,000. In an account earning 3% interest, so that rate would be 0.03 after converting it to a decimal. And the time was also 1 year. So let's think about the amount earned in account 2. P times R times T, so 7,000 times 0.03 times 1. T is 1. So 7,000 times 0.03, that produces $210. So we earned $60 in the first one and $210 in the second one. So we just need to add that up. So we can say, therefore, the total interest will be the $60 plus the $210. And that result is $270. So I'll say Gavin will earn a total of $270 from the combined accounts. All right, let's see if I can move that a little bit. So we just had to use the formula 2 times here because there were 2 separate accounts, and then we add the results together. All right, let's look at a slightly more complex problem. This one says Samira had $8,000 to invest, so that's some total amount. She invested some of it in a savings account that paid 4% interest. Notice this time they're not telling us how much is in the account. And then the rest in a certificate of deposit that paid 6% simple interest. In 1 year, there's our time frame. She earned a total of $360 in interest. How much did she put in each account? So now we know the total amount of interest, but we need to backtrack and find out how much was deposited in each account separately. So this can be a little bit tricky, but it's helpful just to write out what we do know. We do know the total amount invested. So the total amount from both accounts is equal to $8,000. $8,000. And then we're told that the total interest from both accounts is $360. So let's just imagine our first account, account 1. Well, we don't know how much is deposited, so that would be our first unknown, some unknown principal. But we know the rate was 4%, so 0.04 as a decimal. And we know the amount of time that went by was 1 year. So let's imagine account 2. We also don't know how much was put in, but we can still express it in terms of x. If we start with 8,000 and subtract out x, because x was how much you put in the first account, that would give you how much is in the second. So we can describe it as 8,000 minus x. A little bit tricky, but that should work out. And then the rate from the second account was 6%, so R would be 0.06. And then the time was also 1 year. So let's just calculate what the interest would be with this unknown x in here. You can say the interest from account 1 again, we're using the formula I equals P times R times T for simple interest. So interest from account 1 would be P, which in this case is X. We're using this X here. So P times R is 0.04, and T is 1. So we can make this a little bit nicer and say this would be 0.04x. Usually put the variable net on the right side. So if we can know what that is, we can find out how much interest was made. So let's do the same thing for account 2. The interest from account 2. We're still doing P times R times T. For account 2, the P was 8,000 minus X. So 8,000 minus X times R. The rate for the second account was 0.06 times T. T was 1. So we can say this interest, and I'll put the 0.06 in front because you usually see it written like this. So 0.06 times 8,000 minus X. So it feels messy right now, but let's just keep going because we do know how much total interest we should make. These two statements should add up to $360. So if we set it up like that, we can get a little equation that we'll be able to solve for X. So I can say the total interest well, that would be the sum of these two things that we just found. The total interest, which was $360, should be interest from the first account, which is 0.04 times X, plus interest from the second account, which is 0.06 times 8,000 minus X. So notice we have a nice equation in terms of X that we can solve. Let's make some room. So we have these decimals. If you remember from a couple of videos ago, we saw a strategy to eliminate the decimals. And we did that by multiplying by the number of decimal places that we have, the largest number of decimal places. In this case, it's 2. We have 2 decimal places for each of these. So we'll multiply by 100, by 1 with 2 zeros. I'll multiply on both sides. So I'm going to do 100 times 360. This will be equal to, and I'll do 100 times the entire right side. So 0.04x plus 0.06 times 8,000 minus x. You're welcome to keep the decimals. You would still end up with the same result, but this is a strategy to eliminate them and make maybe the numbers a little bit easier to work with. So on the left side, 100 times 360, well, you would just add 2 zeros when you multiply 100, multiplied by 100. So that should give us 360 with 2 more zeros added, so 36,000. equals, and then I'm going to distribute this 100 to both of these terms. When you multiply 100, that essentially just moves the decimal place over 2 places. But you can test it out in a calculator. So 0.04 times 100 will just give us 4x. And then 0.06 times 100 will just give us 6. And then when you have this statement here with a number in front of a parentheses, you just multiply by the number in front if you're distributing into there. So this would be plus 0.06 times, still times this 8,000 minus x. So now we've eliminated the decimals. And let's solve like we've done before. So first I'll distribute this 6 to both terms. So I'll get 36,000 equals 4x plus 8,000 times, or I'm sorry, 800. Let's see. Ooh, let me take a step back. This was 8,000, right? All right, just making sure. There was a little error in my notes here. So 8,000. So 8,000 times 6 will give me 48,000, then minus 6x. Okay, now I will combine some like terms. So I have 36,000 equals, here we have 4x minus 6x. So 4 minus 6 will give us negative 2. So negative 2x plus 48,000. So now let's subtract the 48,000 from both sides. So 36,000 minus 48,000 will give us negative 12,000. And then we still have this negative 2x on the right side. So the negatives feel weird, but if you notice here, they're going to cancel. Let's make a little more room. So I'll divide by negative 2. Divide by negative 2. When I divide by a negative, negative divided by negative will become positive. So we have 12,000 divided by 2 will give us 6,000. So this means, remember x was the amount in our first account. This was the principal from our account 1. So I can say in our first account, that was equal to x. We have $6,000 deposited in. And then in account 2, well, we said that was 8,000 minus x. So that would be 8,000 minus 6,000, which will give us 2,000. That's how much is in our second account. So it was asking, how much did Samira invest in each account? We'll just answer in that context. Say Samira deposited $6,000 in, I'll relate it to the rate. So that was in the 4% account. And $2,000 That was in the 6% account. So definitely a tricky problem. But again, it's helpful to write out what you know initially, and whatever is unknown, you can use a variable. And then once that is set up, we can try to convert things into equations that we can then solve for that unknown. And then we just need to answer in context to the problem. All right, our last subsection is on mixture problems. So this would be some chemistry application. So it's saying a chemist needs to make 24 liters of an 8% acid solution. She will make it from some 6% acid solution and some 12% acid solution that is in the storeroom. So she's working with what she has in the storeroom to try to make the certain kind of diluted solution that she wants. So we need to find out how much of the 6% solution and how much of the 12% solution she should use. So these can be tricky. It's helpful to think again about some total amounts. We can think about, well, the total amount of, in terms of like liters, we can think the total amount of 8% acid, like the total amount of acid. So we have 24 liters in total, and 8% of it is the acid. It's an 8% acid solution. So let's find like the amount of acid. We can find 8%. So 0.08, that's 8%, moving the decimal place over 2 spaces, of 24. And this will give us the liters of basically pure acid that's in that solution. And then we can think about how much acid we have in the 6% solution. So the amount of the 6% solution, which we don't know how much we're going to use, so we can use an X for that amount. And then since it's 6% acid, we can say 6%, so 0.06 of this amount, so 0.06 times X, will give us the amount of liters of acid in that solution. And then let's do the same thing for the 12%. We'll say the amount of the 12% solution well, if there's 24 liters total, and we used X amount for the 6%, the remaining would be 24 minus X in liters. And it's a 12% acid solution, so if we were finding the liters of pure acid, it would be 12%, or as a decimal, 0.12, moving the decimal place over 2 positions, times this amount, times the 24 minus X. And that will give us liters of acid here. So our overall solution needs to be 8%. And we're going to add up some amounts of these 6% and 12%. So let's write this out. We would have some liters of acid in the 6% solution. That's our first one here. And then we take some, we're going to add to this, we'll combine it together with some liters of acid in the 12% solution. This total should be the same as the liters of acid in this overall 8% solution. And we found what each of these would be represented as here. So let's plug these into this statement. So we said liters of acid in the 6% solution, we're describing that as 0.06x, plus liters of acid in the 12% solution, which is this statement, 0.12 times 24 minus x. This should be equal to the overall liters of acid in the 8% solution, which we said is 0.08 times 24, getting that from up here. All right, so kind of a tricky setup, but just think in terms of the total amount of acid in the overall solution, and then how we need to add up to it. So let's do a similar technique last time. We'll clear out the decimals by multiplying both sides by 100. I'm going to multiply this side by 100 as well. So that's going to turn this 0.06 just into 6x. It'll turn the 0.12 into 12. We still have the 24 minus x. And then it's going to turn this 0.08 into 8, because all the decimal places will move 2 places. That's what happens when you multiply by 100. All right, so now let's distribute the 12 to both terms. So we have 6x plus 12 times 24 is 288. 12 times x is 12x. And then 8 times 24 will give us 192. Then we can combine like terms. We have 6x minus 12x. 6 minus 12 will give us negative 6. So negative 6x plus 288 equals the 192. Then I'll subtract the 288 from both sides. So I got negative 6x. 192 minus 288 will give you negative 96. And then let's divide by negative 6 on both sides to solve for x. So it'll clear out on the left side. So I'll get x equals negative 96 divided by negative 6 will give you a positive 16. So what was x? We had said that x was this amount of the 6% solution. So we're almost there. We can say the amount of the 6% solution is x, so that is 16 liters. And then we said earlier the amount of the 12% solution, we had said that was 24 minus x. That's how we defined it up here. So 24 minus 16 will give you 8 liters. So that's our two amounts. We can say the chemist needs 16 liters of 6% solution and 8 liters of the 12% solution. So these mixture questions can be a little bit tricky. Um, my suggestion is to think about some total amount that you have of like what is the percentage? In this case, it's percentage of acid. So we have some total amount of liters that we need, total amount of liters and a total amount of acid. So that will let us know the total amount of liters lets us know how much liters we should add up to, and then the total amount of acid will help us set up this equation down here because we need some total amount. And so we can find out the amount of acid in each separate solution using x as our unknown. And then we can define the other unknown in terms of that same x, which we did here. So it's helpful to write out in word form. We have some liters of acid in 6% solution plus another liters of acid in 12% solution should equal our total amount. Then convert it into equation and solve. So yeah, these can be tricky. I think the textbook uses a kind of table method where they set up a table, which might be helpful too if you want to check that out. But as long as you're careful, you should get to the correct answer. Okay, this was on section 2.4, kind of a long section. So we solved basic percent problems. We solved some applications involving percents, some applications involving percent change, so usually involving some kind of discounts, applications involving simple interest, and then we just finished off looking at some mixture problems. Okay, that'll be all for this video, and I'll see you next time.